Welcome. In the world of Linux, you can have a single file that looks like it's in 2, 5, even 10 different places all at once. But how does that even work? Today, we're going to demystify file links. We'll break down the huge difference between a soft and hard link using a really simple experiment. So let's dive right in.
Seriously, how is this possible? How can one file exist in multiple locations at the same time? And I'm not talking about just making a copy. We're talking about two completely different paths leading to the exact same chunk of data. In Linux, we do this with links, but as you're about to see, the kind of link you make, well, that changes everything.
So we're going to create two kinds of links, a hard link and a soft link. And you know what? When you first look at them, they seem exactly the same. They both open the same file, you can read the same data from them, but don't let that fool you. What's happening under the hood is completely fundamentally different. Here's our little lab setup. It's simple. We've got our original file. From that one file, we're going to create a hard link and then a soft link. So that's three different names, right? But are they pointing to one, two, or three different things? That's the big question we're here to answer.
Okay, and our first test just adds to the mystery. We'll put the word hello inside our original file. Now, as you can see here, if we use the cat command to read the hard link, what do we get? Hello. Okay, now if we read the soft link, we also get hello. So based on this, they're identical, right? Well, are they?
All right, so how did we even get here? The good news is it's incredibly simple. And really understanding the commands is the first big step to seeing the difference. Let's just walk through how we set this all up.
It's literally just three commands in the terminal. First, touch original file. That just creates our empty file. Second, ln original file hard link. That creates the hard link. Notice the command is just ln. Now for step 3, ln -s original file soft link. See that little -s flag? That's the magic ingredient. The -s stands for symbolic, and it's the key instruction that tells the system to make a soft link instead of a hard one.
Okay, now for the real magic. To see what's actually going on, we have to pop the hood and look at the file system itself. And the secret to this entire puzzle, it all comes down to one single concept, the inode.
So what in the world is an inode? You can think of it like this. It's the file system's true ID number for a file's data. We see a name, like mydocument.txt, but the system just sees a number. That's the inode. It points to the actual ones and zeros on your hard drive and holds all the metadata, like permissions and timestamps. The name is just a label for us humans. The inode is the file's real identity. And here it is. This is our aha moment. When we list the files with their inode information, that's the I and ls-li, just look at that first column. Notice something? The hard link and the original file, they share the exact same inode number. To the file system, they're not a file and a shortcut. They are two equal names for the exact same piece of data. But now look at SoftLink. It has its own totally different inode number. It's a completely separate, tiny little file that does nothing but point to the name original file. That's the whole secret.
So, we've seen the clues, we understand the inode. Now it's time for the ultimate test. What happens if we just delete the original file name? The very thing they both seem to rely on. This right here is where the difference between them becomes crystal clear.
And here we go. One simple command, rm original file. We are removing the original name we started with. The links are now on their own. Let's see what happens. And bam, here's the result. Over on the left, we try to read the hard link, and it works perfectly. Hello is still there. But on the right, when we try to read the soft link, the system just gives us an error, no such file or directory. The pointer is still there, but what it was pointing to has vanished. The soft link is officially broken. So what does this tell us? The hard link never actually cared about the name original file. It only ever cared about the inode, number 123456. As long as that inode and its data exist, the hard link works just fine. The soft link, though, it was basically just a sticky note with the address original file written on it. Once we got rid of that name, the note is pointing to nothing. And our final status check confirms everything. Look at the output now. I know 1, 2, 3, 4, 5, 6 is still there, but look at its link count in that third column. It's dropped from 2 down to 1. Why? Because we removed one of its names. Hardlink is now the last remaining name for that data. Meanwhile, the softlink file still exists, sure, but it's now pointing to a name that's gone. It's a dangling, broken link.
Okay, so let's wrap this all up.
Let's distill everything we just saw into a really simple, clear takeaway, because understanding this is absolutely key to managing files effectively on any Linux or Unix-like system.
This right here is everything you need to know. A hard link points directly to the file's data, the inode itself. A soft link, on the other hand, just points to the file's name. The analogy here is perfect. A hard link is like having a second key to your house. If you lose one key, the other one still gets you inside. A soft link is just a sticky note on your fridge with your house's address on it. If your house gets demolished, the sticky note is still there, but it's pointing to an empty lot.
So there you have it. That's the core difference. The next time you need to create a link in Linux, you can ask yourself the right question. Do I need another direct key to the data itself, a hard link? Or do I just need a flexible shortcut that points to a name, something that might even change later, a soft link? Now you know enough to make the right choice for the job. Thanks for tuning in.